Hello, my name is Mathieu Lienard and welcome to the second video of this demo on doing automated incident response and forensic analysis to an attack on a web application server. In the last video, I presented the infrastructure deployed for this demo using 4 CloudFormation templates, which I have now released on GitHub. You can check the link below if you want to test it by yourself. Before doing the demo, let me first present the incident response automation based on a step function and lambda functions deployed by the force template. When we will SSH in one of the web application server through the Bastion host and simulate an attack, it will be picked up by GuardDuty. GuardDuty will send the finding to the CloudWatch event bridge. This will be captured by an event rule, which will trigger a lambda function. That lambda function will parse the GuardDuty finding to extract information and trigger the incident response and forensic process, which is controlled by a step function. The first step of that process is to execute a lambda function, which will send a notification about the GuardDuty finding to the administrator's Slack channel. Then it will launch a lambda function which will create a memory dump of the instance under attack and save that memory dump onto the instance local disk. The process can take some time, and the step function will wait for it to complete before proceeding further. Once done, the instance is isolated by applying to it an empty NSG, essentially setting its firewall to not allow any traffic in and out. This is done after the memory dump, because to perform the memory dump, we need to be able to access the instance to run commands on it using Systems Manager and installs the tools to perform the memory dump. At this stage, the instance is isolated. I represented it here on this infrastructure diagram as outside of the autoscaling group for a matter of convenience. But the instance is not deregistered from the autoscaling group. The next lambda function sends a notification that the instance has been isolated. The next one creates a snapshot of the instance volume. So the snapshot will include the memory dump, which was saved locally. The step function then launches a lambda function which will create a forensic instance and waits for it to be up. If we go back to our infrastructure diagram, at this stage the forensic instance is installed on the Quarantine VPC private subnet, and all the forensic tools are installed on it at startup. Back to our step function. Once the forensic instance is up, it attaches the captured snapshot to the forensic instance. If we look back at our infrastructure diagram, the snapshot we captured of the instance being attacked is attached to the forensic instance in the Quarantine VPC for analysis. Next, the step function waits for the forensic instance to show up in Systems Manager. Once it does, it starts the forensic by launching a first lambda function, which will use Systems Manager to run commands to perform the volume snapshot analysis. The step function waits for the commands to complete. It then launches the lambda function, which will launch the System Manager run commands again, this time to run the memory forensic. It then waits for it to complete. Once completed, it sends a notification to the administrator's Slack channel. If we go back to our infrastructure diagram, while all this is happening, the autoscaling group should have noticed that one of the application server hasn't been responding for more than 5 minutes and will have provisioned a new one and install the application code on it. The autoscaling group will send a SNS notification which will be forwarded to the Slack channel. At this stage, our application has auto-healed. When the forensic is complete, the step function will launch a lambda function to stop the attacked instance. However, depending on the time this entire process takes, the instance, because it is unreachable, might have already been terminated by the autoscaling group. And finally, the step function launches a last lambda function to send a notification to the administrator's Slack channel. So this is the entire process. Let's go try it by hacking into one of our web application servers. Let's first connect to the web application URL and confirm the traffic is load balanced on the two instances. I am already SSH through the Bastion host into one of the Nginx web application server. I'm SSH into 3.43, which is one of the two Nginx servers. As mentioned in the previous demo, the CloudFormation template creates 3 shell scripts on these instances to simulate 3 types of inappropriate behavior. One is data exfiltration using DNS, the other one is cryptocurrency activity, and the third one is querying a domain name with known command and control servers. Let me run the DNS data exfiltration one. This will be picked up by GuardDuty, but will take some time, so let me pause the video and come back when the incident response has been triggered. Welcome back. GuardDuty has reported the incident, and we can see here triggered the step function to start the incident response. It started the incident response process, and I received in the Slack channel the information about the incident. And in the run command of System Manager, it is currently running the memory dump of that instance. The memory dump is now complete, and the instance has been isolated. The name has changed, and if I access the application load balancer URL, now only one instance is responding. In our Slack channel, we received a notification about actions already taken and what will happen next. Currently, a snapshot is being created. And now the forensic instance is being launched with all the tools it needs for the forensic analysis. The instance is currently being launched. The volume has been attached to the installed forensic instance, and the step function has been waiting for the instance to show up in System Manager. Once it passed the checked, so it launched the function to use System Manager run command to perform the forensic. So if we go in System Manager, we can see the commands being launched to complete the snapshot forensic. The snapshot forensic has completed, so it is now performing the memory forensic analysis, which we can see here in Systems Manager, and which is already completed. Now all forensic analyses have completed. So in my Slack channel, I received notification with a link to the S3 bucket containing the data and primary analysis. So if we go in the S3 bucket, we can see a copy of the snapshot analysis here, the memory dump performed by Lime, and in the text files, outputs of some of the very basic reports this forensic analysis is doing. So for example, if I look at the memory dump forensic analysis, and I open the results of the PS3 command, I can see here all the processes which were running at the time of the incident. For example, my Nginx application, the Systems Manager agent running on that instance, and etc. This is another analysis of a PS scan on the memory at the time of the incident. Here, a full list of the file system, and if I open this file, I can, for example, see day by day all the changes that were made on the file system. And finally, if we look back at our Slack channel, that we'll receive notification from our autoscaling launch group that it launched a new instance to replace the one which we took down, and that it terminated the instance we isolated because it was not responsive. So if we look in our EC2 console, the instance which we attacked and was isolated has been terminated, and a new Nginx web application servers has been provisioned, as we now have again 2 servers. So if we go back to our application web page, 2 instances are again responding, one of them being a new one with a new IP. And this completes this entire automated incident response and forensic process. That's it for this demo of a fully automated incident response, forensic analysis, and application auto-healing. How cool was that? I hope you enjoyed the demo. I have released all the code and CloudFormation templates on GitHub, so you can go try it by yourself. Check the link below. Thank you for watching, and see you next time.